uh, is fundamentals of power distribution networks.
Probably the slide change you will do for coach remote.
यहाँ से कर।
Next 10 is that. कहूँ ना लेकिन आप अपने आप थोड़ा. All right, so very good evening, and today, as I told you in my introduction during inauguration session, why advanced distribution system analysis and operation is important. Next. So today we'll be talking about the basics of power distribution system. One important thing I like to highlight, hope I'm audible loud and clear. At least one can say yes. Am I audible? Yes. Very good. Thank you. So whenever we talk about smart grid, a smart grid, it's basically a modern distribution system. So when I talk about introduction to power distribution network, it may so happen that some of our young participants may be willing to know what is smart grid, but may not be having thorough understanding about basic distribution system, which is very, very close to smart grid operation. So we'll be talking about distribution network, and then we'll talk a little bit about transmission system and distribution system, because there is a bit of confusion that the smart grid is not limited to distribution system. It can be also extended to medium voltage transmission networks. And then we'll talk about the architecture of distribution network. And then it is quite important to understand the impact of distributed energy resources on distribution grid. Because when we talk about basic smart grid and even modern smart grid, we don't talk too much on the challenges on distribution system. But we focus on operating a renewable energy sources in a smart grid, the control mechanisms, but we don't see what is the impact on a distribution system if many more smart grid or distributed energy sources are being embedded into a conventional distribution system. Because all the distribution system in this country, they were ill-designed for accommodating smart grid in this country. So you talk about smart grid, when you put it on a distribution system, which is existing for last 50 to 70 years, how my smart grid is going to work become a question. Then when you talk about enhanced because of the distribution system limitation, acceptability, evacuation of renewable energy, the DR hosting capacity assessment become mandatory. For example, at MNIT Jaipur campus, we have a load of let's say 3.5 to 4 megawatt is my peak. Then how much PV or distributed energy resources must be integrated in my distribution system so that I'll be able to operate successfully. Also an important thing. So simply modeling a smart grid or MNIT campus where the distribution network is not capable of accepting it becomes. And this may be true in any campuses in the country. Operational challenges associated with the DR integration of the distribution network, that also we discussed in detail. Now moving to power distribution network. I think this is a very standard diagram you might have seen in most of my slides in the past. What I wanted to say, the first definition is very important. Even today, anyone talk about electrical power grid, the definition is not very clearly known to most of the people in this electrical industry. So an electric grid is a network of synchronized power providers. Means having n number of generators, those are synchronized, and consumers that are connected by transmission and distribution lines are operated by more than one control centers is known as my electrical power grid. I think that's very unique, as you all know, because some of you may be attending this course for the first time, so it is my responsibility to get into details. You could see there is a thermal power plant or the nuclear power plant at the end, and then the power is getting transmitted through transmission corridor. Then we have actually, lowering down the voltage by a power transformer, and then we have the distribution system, and that distribution system is now integrated with PV, with wind, and further rooftop PV, as well as electric vehicles and battery chargers could be a part of the residential unit at which the rooftop PV are integrated. Next. Now, this is what very interesting. Power system is the most complex device in the mankind history. Because to me, power network is a device basically. Right? If I take a single entity, uh, so so why do I emphasize on it's the most complex device in the mankind? Because to me, Indian Railways and power networks of India are normally it was not very small. It's a very big. Okay. So I'll tell you actually why it is a complex device in the mankind history, because the amount of complications, the amount of frequencies, variations, the amount of power movement from one corridor to other, with n number of actually strategies, become a very challenging. Next. Now, billions of independent and connected devices, millions of independent and connected images, different needs and possibilities, anything can happen. Simultaneous production consumption with no storage. Today, any power system specific to Indian power system is operating without any backup. Okay, system is operating without any storage mechanism and still it is working. It's not a joke, imagine. Without having a battery backup, operating a system is really risky. Means you get the energy and you consume immediately. Live matching, of the energy. If you technically imagine, we are so lucky sitting in this room, but imagine the energy, the management goes behind this meter. Then physical specifics, frequency, voltage, dynamics, oscillation, everything is actually oscillating every second. Load is varying, generation is varying, frequency is varying, voltage is varying, flow is varying, current is varying, everything is keep on varying. And above and all, in case of power system grid is the greatest engineering achievement. It is the design and operation are much more complex than aircraft. Many times people talk about space technology, but power network is more complex than even space technology. That's what actually we wanted to prove. And we see to think we can randomly connect new devices to it with no overall game plan in mind. Now, what happens when we go for a space technology, even a satellite technology, we have everything in strategy, very well planned, and we operate. But in electrical network, tomorrow you buy an air conditioner and you put it without taking permission of anyone. You conduct a marriage function, put thousands and thousands of watts without talking to anybody. Still the system runs. And that is why it is beautiful compared to any space technology, and it is the most important device of the mankind actually. And this will be helpful when you launch electrical engineering to first year students. Probably this is how actually you should introduce this course. Now, very basic understanding about architecture of electrical power grid. There are three components, as you all know: generation, transmission, and distribution. But here I tried my level best to present in a different way, because when you talk about generation, it is of all the sources: coal, oil, natural gas, nuclear, renewable, solar, wind, hydraulic, everything is part of it. And you could see the top of the ladder, we could see generators. Then we come across transmission. Transmission are two different types: high voltage transmission as well as medium voltage transmission. And they basically disperse bulk movement of electrical energy from one layer to other. And finally, we come across the distribution layer. So it is the delivery of electricity to consumers at lower voltages. So there is a junction point between distribution system and transmission system. And that junction could be 66 kV. That junction could be, 33 kV. That junction could be 11 kV. So there is a point where low voltage transmission network and high voltage distribution network meet together. Next. Now, why actually distribution system is important? And keep on talking now. Because in the past we said directly we got into technology, renewable energy, smart grid. But this time we are a little bit, stressing on the importance of distribution network. And finally, we'll come to smart grid. Reliability. Reliability is one of the area which is very important, But the transmission reliability is quite strong in any part of the world. But the distribution system reliability is always in question. Imagine that if my transformer fails, then I'm not able to replace the transformer by another transformer within, let's say, minimum time. Or I do not have another n minus 1 contingency for my transformer. Then whatever I do in my smart grid is not going to, right? So reliability of distribution system become an important topic. I'm just connecting to all the points to smart grid now. Then economic growth and development. Distribution network are critical for economic growth. For example, when you have an industrialization, which is mostly at 11 kVA or 33 kVA. So if you do not have a greater reliable distribution network, your country cannot achieve economic growth because the industry needs a very reliable, well-connected actually power supply. And then safety and scalability. Now, well-maintained distribution network. Now, today, if you go to Delhi and in the area of Chandni Chowk, you will be scared to imagine even distribution network can happen like this. It's like a mess. Why actually so far to Chandni Chowk? Even in Jaipur, you can see some junctions are very scary. You say, "Kya ho gaya? What is happening here?" And this is not A or B, it is across the country. Most of the distribution networks are keep on adding from time to time. It was never been planned. The distribution system got expanded to a point, one house, two layers, three layers, three rental houses, 20 shops, keep on connecting till the system collapses. So we will not allow the distribution system to live properly until unless it dies. That is what we are trying to do there. Right? So we'll keep on loading until unless it dies. So facilities renewable energy grids. And in the meantime, one actually putting a lot of pressure on a person so that it cannot bear, am I right? The load. And same time you're making that fellow smart. Means you are putting 200 kg of load on the top of the head and also giving a Apple mobile in the pocket. How he is having a load? He may not be having time to see the mobile. Am I right? So that is what the distribution life will be. Because only if you take up the load, then only you can see the mobile. Am I right? That's what we are doing today. Putting the system under too much of stress and then putting sophisticated control mechanisms, renewable energies. So that need to be understood in the power. Next, please. So there is a long history starting from 1880, where we had distribution system feeding arc lamps with the first device, and then slowly 1890 the DC network in New York City, and then 1990 we proved that AC is better than DC network. 1910 mainly 2 and 4 kV distribution system network is in operation. 1920 auto recloser or circuit breaker being evolved. 1930, we came across switchgear devices. 1940, reclosers. 1950, 15 kV distribution systems. 1960, actually transformers. 1970, we moved to 25 to 35 kV distribution. You see 2, 4, 10, 12, 30, 35. The distribution system rating is keep on increasing. 1980, we came across modern transformers and arresters. 1990, we came across actually, computers, digital clocks, smart controllers. That is again 2000. We came across the emergence of distributed scale generation technologies. 2010, automated meter readings, automation, smart grid technology started coming into. So now, what I wanted to highlight, 1880 to 2010, almost 100 years, we had a distribution network story. And 2010 to 2025, 15 years of the smart grid story. So it is not enough to study what is happening in 15 years. It is also important to know what has happened before 100 years. Am I right? So 2020, more integration of distribution generations, microgrid, automation, and control started happening. Next, please. So if you see the traditional distribution networks, which is very, very classic, you could see this is how the distribution system network normally look like. And we all have grown up in a street-like structure, not like apartment structure before 40, 50 years, where we used to live like a series of houses. And each and every house boundaries are also touched. That is the original story. Rural and the medium townships where all the houses are continuously common walls. Okay, that is how actually Indian civilization started and then slowly became very independent detached walls. This is how it will. Then now slowly we came across capacitor banks, voltage regulators, diesel generators as a backup, and then this is how the modern system becomes slightly becomes smarter. So the backup power supply from diesel generator, voltage regulator for voltage variations. Why voltage regulator? Because of the voltage of this particular bus need to be maintained at a constant 1.0 per unit, it's 440 volts or 11 kV, and which is not possible because the load is keep on changing. So we need to have a regulator which can maintain the voltage at the same time. And most of the time, actually, capacitor bank is very important because of reactive power injection. Next, please. So here, I mean, so what are the basic features or the properties of this system? The power flow is considered to be unidirectional. It moves from the substation to the consumer all the time. All the time it goes in one way. I don't know actually how many of you could recall. Anyone of you live in the end of the street of your village or city? Fortunately, I used to live at the end of the street. Means the end of the street means there are two ways. There is a street. You can come this way or this way. But we say end of the street because the transformer, the substation transformer was at the end of this street. So and hence our house was almost here. So we consider that we are the end of the street. And I still surprisingly, my mother used to say 5:45, switch on the tube light, switch on the tube light. She used to shout at us. What is the reason? Because if you do not switch on the tube light before 5:30, here 5:45, 8 o'clock it is next to impossible because of the. So that is not the voltage is. But today, if you go to cities like Mumbai, or Chennai, or Delhi, you will find actually small capacitor banks are being placed at each and every pole, even to compensate for voltages at each and every pass. So higher energy losses lead to additional energy cost, and distribution system to experience the maximum energy loss, which is almost 3 to 5% in transmission and 18 to 20% in case of distribution system. That is due to two things. One is the current is very high because when the current is more, the I square R loss will be very. And then low voltage problem at the farthest end, as I told you, similar to this is how it happens. And the diesel generators are connected to supply power during peak hours, means which is not true in case of small towns, but city like Jaipur, whenever there is energy peak, we do not know, but we don't experience power there. That is because there are some diesel generators which are operating during peak hours. Voltage regulators and capacitor banks used to improve voltage profile in the network so that all the time you get constant voltage. Now, this is an important analysis which is very, very interesting outcome. In 2024-25 data, the carbon emission CO2, it is very clear. The carbon emission, if you see, which has been increasing over the years. So CO2 emission from using coal is increasing every year. If you see the characteristic, which is keep on increasing till the last point. But in last couple of years, you could see the CO2 emission has drastically reduced. Why it is happening? Any clue?
Renewable energy.
Because thermal power plants generation has taken up. Basically, we stopped adding thermal power plants. So the carbon emission got reduced drastically in last couple of years, and it is going to fall much more in next 5 to 10 years. Next, please. Now, the generation mix scenario, as you could see, one scenario in 2022, a lot of mixture and the majority is still, is fossil fuel, which is very, very high. The solar, which is extremely low, almost 1/5 of the fossil is belongs to solar, But I'm very confident in a couple of years it will be half of it, and 10 years time it will overtake even the fossil fuel generations. Next, please. So this is the Indian scenario. As you could see, the different combinations. As you could see, in case of percentage share, fossil fuel share is still 50%, and rest of them is another 50%. So the total installed capacity as per 28 February 2025, which is just 1 year back, 11 months, which is 470 gigawatt. And you could see the fossil and non-fossil are very close to each other, approximately 50 each. Next, please. Now, status of DR integration in India, rooftop solar, which is coming up very aggressively. And recently, the government, Prime Minister of India recently announced the concept of each and every house can have their own PV with subsidized price, so that they did not take energy from the grid. So rooftop solar is coming in a very, very big, because until unless government provides incentive for a rooftop solar, it is almost next to impossible for anyone to do it. So now the government is there with public. So 99% actually, I'm very sure a lot of rooftop solar is going to come up. Now electric vehicle also have, watching it is not going to stop. You'll be surprised there are almost 50 lakh electric vehicles were there on road in India before 1 year. So currently it is almost 60 lakh electric vehicles on road, which is not a small number. It's a very, very big number, right? And then small wind, which is taking up 3 megawatt of small wind. Because I will tell you, small wind is in a very important area, because we say most part of the country is not prone to wind energy, which is not true. हवा तो चलते रहता है. So I think similar to a fan, normal table fan at home, we can have wind power plants, which can be fixed on your windows. And similar to PV panel, you will get some electricity every time. So in some of my visit to Europe, I'm surprised to see the houses are designed in such a manner. There are hundreds of micro wind power plants are placed in the window itself. Okay, and they keep on rippling and then giving some energy, somewhat, somewhat, somewhat. And fine, someone is responsible for LED bulb, someone is responsible for air conditioning, and some. Right? So if you imagine that way, that means you can capture n megawatt of energy through micro wind turbine, but for that technology and cheaper cost. Again, government has to teach it. And then battery energy storage system, I think we were very smart. If you see, each and every house in this country had a UPS in the past. Right? So whenever there is no power, the UPS will switch on. So we had batteries. So similar to battery energy storage system is going to come up very big way. And as of March 2024, we had 219 megawatt hours of battery, which is not very big, but still I'm very sure. What they're claiming is 1.6 gigawatt hours of storage available to us in the year 2027. Now, very, very important definition. What do you mean by distribution system is fine, but what is active distribution system? What is active distribution system? Active distribution system is a system which also having variation in not only loads but also in the energy resources, and that is known as actually not only a passive network, because we had a passive network where the grid gives you power and you consume and you see that's. But now you connect renewables left and right, the energy is coming all the time. Somewhere it is moving more than your load, sometimes less than your load. So if you could see the wind turbine, the sun's movement, the storage charging of the battery, the electric vehicle connected to the grid, how dynamic it is, right? And hence, and the diesel generator is sometime operating, sometime not. So considering this dynamics, the distribution system, what you will learn as of now, will now, in this condition, it can be named as active distributed network. The penetration of previous one, the penetration of distributed energy resources are increasing in recent years at distribution level, This is due to environmental concerns, cost, competitiveness, energy security, technological advancement, and policy support. And because of which today, most of the distribution system in the world become active. So, next. Now, one of the small example, which is very commonly available, you can see the IIT Roorkee campus, where we have bit of research in the past. You can find a couple of transaction papers which talks about the system in detail. We had 21 number of substations, load 8 megawatt, minimum 3 megawatt, 2.7 megawatt of it PV, 35 locations. I mean, the battery energy storage system of close to 425 kilowatt hour. Distribution network is mostly underground. RTUs at every substation. SCADA is inbuilt. So this is a perfect active distribution system example. We'll talk about this in due course of time. Next, please. This is what the basic introduction to our distribution system. Moving to the second part, please. Hope I'm audible, loud and clear. Loud and clear? Okay, very good. So, yeah. Any instruction to the students for attendance and other things that you can say at the end of the day? So, let us understand a little bit about how transmission and distribution network varies. So, as of now, we learned about distribution system and active distribution network. Now we move to similarity and dissimilarity between distribution system and transmission system. In case of distribution system, when you talk about transmission system, it is exactly same as the previous diagram. Only the top layer is popularly known as transmission network. And you could see the AC transmission takes place at 132 kV, 200 kV, 400 kV, 765 kV. And also, we may have HVDC network, which are of 100 kV to 800 kV. Sub-transmission, 22 kV, 33 kV, and 66 kV, which is nothing but the joint between distribution system and transmission system. The frequency across the world may operate at any frequency, but mostly it is 50 or 60 hertz. And transmission network equipments, which are very commonly seen, what is transmission substations, power transformers, and transmission lines. Next, please. We will be experiencing protective devices, reactive power support. In case of protection, we'll be having circuit breakers, relays, and isolator. In case of actually reactive power support, we'll be having capacitor banks, reactors, and HAT devices for some extent. Now, in case of HVDC converters, we'll have AC-DC conversion for HVDC lines. There's a question comes to mind, why do I get into HVDC transmission lines? There are two important things. All of you please remember. I think this question have been asked by many in the past. When I used to ask students actually, why do we go for HVDC? The answer is not clear to me. Why do we go for HVDC?
Long distance bulk transfer. Long distance and bulk transmissions.
Low power loss. Because there is no reactive power. Okay. Anything else? Agree. Current we will not say because current will not. But actually reactive power movement is negligible. But by the time you have your switching losses, that also will be additional one. So I think what has been proven as of now, if you go for a very, very long transmission, for short transmission, HVDC will experience more loss. Okay, the transmission loss will be reduced, but the switching losses will be very, very significant. But if you go beyond 600 miles, okay, or underground up to 30 miles, okay, then probably people say the HVDC is much more meaningful than your HVAC. Next, please. So, what are the benefits? So, lower cost than AC for long distance, that is beyond 600 miles, and 30 miles for underground submarines. Controlled power flow, owner has control the limitation of short circuit current, okay? High speed electronic clearance of temporary faults, Transmission at reduced voltage when line insulation is damaged. HVDC transmission results in lower losses compared to AC, especially over long distances. Now, this is the transmission network infrastructure. Just wanted to highlight how big our network is, and at each and every voltage level, how much circuit kilometers of transmission network is currently available. Next, please. Moving to quickly distribution network, there are quickly different things. We can say 6.6 kV, 11 kV, 3.3 kV, 400 volt, 230. We have single phase system, two phase system, three phase system, again 50 and 100, 50 and 60 hertz. So electric power distribution is the final stage in the delivery of electrical network. That is the low portion. So if you see the diagram, that first two blocks belongs to transmission, top and bottom two blocks belong to distribution. Next please. Similar to transmission system in distribution network also we have many equipments. One is your distribution substations, and we do have actually relays, breakers, bus bars, am I right? And then distribution transformers, which are normally, have you seen distribution transformer? The small cylinder like a water heater, okay, being hanged. Like structure actually. So further step down is actually 415 to 230 volt. Next, please. They're mostly installed in poles. And then we talk about feeder, a very commonly used term. So carry electricity from substation to local area at medium voltage. So overhead feeders common in rural and semi-urban India. Underground feeders which are common in urban areas. Okay. Distributors supply power from distribution transformer to end consumers. That is 415 volt, three phase to 230 volt, single phase supply. Then you have service mains, 230 volt for homes and small shops. Industries, commercial buildings will experience 415 volt. Next. So smart meters, which is a very, very common device. We have capacitor banks, voltage regulators. I mean, most commonly devices you see in case of distribution systems. Next. And this is again the distribution network infrastructure. Unfortunately, the distribution network infrastructure are not very well maintained in this country. But one thing is very clear. There are two columns I have given you, 2022 and 2030. So 2022, you could see the figures, and 2030, actually, we almost expect 10 to 20% rise in our actually infrastructure of distribution system, considering the population growth. And this is continuing to grow because we captured almost each and every land available in this country, and we all lived and captured. Now the India is now saturated. The population is keep on increasing now. The distribution network is the only way to reach to each and every corner of this country. Next, please. Now, if I compare transmission line versus distribution lines, I mean voltage level, you could see the differences: 33, 66, 132, 220, 400, 765, plus or minus 800 kV, and low voltage distribution network of 11 kV usually. Current carrying capacity, it is low in case of distribution system, and it is large in case of transmission system. The system which is normally balanced in case of transmission system, and it is 100% unbalanced in case of distribution system. Next, please. Next. Yeah. So now the moving to types of line, we call it is long transmission, medium transmission, short transmission. But distribution system, we say radial connected, ring mains, and interconnected networks. Line support are normally steel towers, but in distribution it could be rail poles, RCC poles, and sometimes it is wooden poles. Next, please. Line maintenance, actually, transmission line actually requires too much of maintenance. Our distribution line requires less maintenance, or sometimes we consider that they do not need any maintenance. Okay, next please. This is very, very important slide. I request everyone to have attention. This slide is almost my favorite in one sense. I mean, the R by X ratio or X by R ratio, which is slightly different in case of transmission and distribution line. So X by R ratio is higher in case of high voltage transmission line. However, it is lower in case of distribution lines. But if you see the voltage level, if you see the voltage level, no, the way it increases from 22 kV to 765 kV, the X by R ratio is keep on increasing from 1.93 to 30. Most of the power engineers in this country may not be very sure about what is X by R ratio. Okay. So, what does it mean when the X by R ratio is keep on increasing for high voltage? And hence, whenever we draw a transmission network, we simply write it is an inductor. We ignore the resistance because of this figure 30, because of this figure 20, because it is 20 times higher. The reactance is 20 times higher than resistance component, and hence we ignore the resistance instead of RL. We simply put an inductor. But when you come to distribution system, it is a low voltage network, so it will be the X will be much, almost very close to 1. When you say X is very close to 1, in 22 kV it is 1.93. If I go to, let's say 11 kV, then X by R ratio will be very close to 1. Very close to 1 means X and R will have equal share. That means I cannot afford to ignore the resistance that I used to do in case of transmission. Is it clear? Very good. Next, please. So moving to losses in transmission line versus distribution line. Distribution lines carries lower current as compared to transmission lines. Thickness area A of conductor is lower. Resistance is higher. I square R loss will be higher as compared to transmission line. So you could see the transmission line losses, which is close to 1 to 1.7%, and the distribution system is 5 to 5 to 8%, let's say. So almost 4 to 5 times higher than distribution loss. But you'll be very surprised to see in India the transmission losses is close to 4%, and the distribution loss is close to 18%, which is very, very high. Next, please. So with this, we come to an end of today's lecture. A very brief introduction about distribution system, transmission system, and when we meet next time, we'll get into more details on electric distribution system. Thank you.
So, thank you very much, sir, for the inaugural lectures. Lecture 1 and Lecture 2 have completed. Now, we end here today's talk, and tomorrow at 5 p.m. we will be again meeting at the same platform. Those like who has not we have sent the invitation of Canvas to you, so please join that Canvas platform where you will be finding this